Hello everyone, welcome back to another AP Physics 1 daily problem. Today we'll be going over question 2 in the MIT AP Physics 1 workbook about energy. With that being said, the description will include the link to this book so you guys can use that to follow along as well. And let's go on and read the question. It says a force F at an angle theta above the horizontal is used to pull a heavy suitcase of weight mg a distance d along a level floor at constant velocity. The coefficient of friction between the floor and the suitcase is mu. The work done by the frictional force is, and then we have our choices. So first off, I would recommend just listing all the equations you need in this problem so you know where to start. So first we will need the work equation because it's asking us what the work is done. So if we remember, work is equal to force times distance times cosine of 180 degrees, and we're asked to force friction. And since the object is moving, it's going to be kinetic friction. So we can just say force kinetic is equal to mu times force normal. And then force normal we can get from our free body diagram. With that in mind, let's go ahead and draw a diagram since we are not given it. So drawing our diagram, we can see that we'll have a suitcase, so we can just say a suitcase, and it's pulled at with a force F at an angle above the horizontal. So here is the horizontal, and above the horizontal, so that means it's going to be right here, and this is the degree. So this is above the horizontal of theta. So right here, this is the angle theta, and this is the force F. And knowing that this force is acted at an angle, we're going to split it into our x and into our y component. So this is going to be force in the y and a force in the x. But we have some other forces acting on it. We have the force gravity, so mg, acting downwards, and we're going to have force normal, which is what we're looking for, force normal acting upwards. And then of course we do have our force kinetic friction, which is what we're going to use, but we know force kinetic is mu times force normal, so there's no need to calculate that since we're going to get it from our force normal right here. So with everything in mind, we need to calculate what our force y and our force x is going to be. Using theta, we can use our trig identities. So this is going to be opposite, and this is our hypotenuse. And if we remember, that is going to be sine opposite over hypotenuse. So this is going to equal sine of theta is equal to opposite, which is force y over f. And to get fy by itself, we're going to multiply by f, multiply by f. This cancels out, giving us that fy is just equal to f sine theta, so we can erase that side. Here we have adjacent, and if we remember our trig identities, SOHCAHTOA, cosine is adjacent over hypotenuse, so this is equal to cosine of theta is equal to adjacent, which is force x, over a hypotenuse, which is the f, and to get x by itself, multiply by f, and just that cancels out, giving us f cosine theta. Now, with that being said, we need to go ahead and make our Newton's second law sum of forces equation. So that would be the sum of forces is equal to mass times acceleration. As I said, this is a big part of physics and it will come up again and again and again. So please try to get that down. So in this case, we're going to want our force normal, and our force normal is going to be acting in the y direction. So we're going to go ahead and say in the y. So first off, we have a force normal. It is acting in the positive direction, so we're going to say positive upwards, downwards is negative, mg is going to be minus mg, and then we're going to have our force in the y is also positive because it's acting upwards, so we're going to have that as positive, so it's going to be plus force in the y, and this equals mass times acceleration. But one thing we need to know is that this object is pulled across the floor horizontally. And since it's pulled across the floor and it's not mentioned that it's pulled vertically or above, that means that there is no motion acting in the vertical component. And if there's no motion, that means there is no acceleration. That means all the forces are equaled out. So we can go ahead and set this equal to 0. And with that being said, we can get all of everything on one side that is not force normal. So doing that, we would get force normal is equal to mg minus force in the y. So we already have one portion of this equation. And to do this, we're going to need the other portion, which is mu. But luckily, we aren't solving for anything. We're just using our variables. So we can go ahead and find our force friction kinetic. So our force friction kinetic is going to be equal to mu times force normal, which is equal to mu times mg minus force is in the y. And with that being said, we can now take this value, force kinetic, into our work equation. Reason being, our work equation is the force, which in this case is the frictional force, the force times the distance times cosine of 180. Doing so, we can go ahead and substitute that in. We can say that work is equal to force, which is the force kinetic, times distance times cosine of 180, 180 degrees. Now that we have this equation, we can go ahead and get rid of this angle over here because cosine of 180 is just -1, so that is going to just bring this out here. So a -1, so right here, this is going to bring it out, so I'll remember -1. Force kinetic is going to be mu times mg minus, and then I'll plug in the force y here, minus f sine theta, and this is all multiplied by d. And this is equal to the work friction. Remember to have a subtitle, work friction. And you might be looking at this and saying, I don't see anything that matches up. And the reason being, we are not done yet. There is one thing that we missed out that will help us in this problem. To simplify this, we need to get force kinetic, frictional force kinetic, set equal to something easier. Because right now we have it equal up here, but this is kind of long. But there is one thing we did forget. In the sum of forces equation, we can make one in the x. Doing so, we would get that the force kinetic is equal to the force x. Reason being that it's dragged along a level floor at a constant velocity. And since that information is so important, we can go ahead and set the acceleration to 0. So instead of talking, let me go ahead and show you what I mean. Doing so, we could get the sum of forces in the x is equal to mass times acceleration. Here we have our negative and we have our positive. So force x is going to be positive, so force x minus force kinetic, so force friction kinetic, is equal to mass times acceleration. But as we said, it's at a constant velocity on the level floor. This is just going to equal 0. And with that being said, they have to be equal to each other, because if we bring it to one side, force x is equal to force friction kinetic. And if we remember, force friction kinetic is equal to force x, and force x is equal to force cosine theta. So we can just say force friction kinetic is equal to force cosine theta. And now we have a way easier variable to plug in for force friction kinetic. So instead of plugging in this whole thing for force kinetic, we can go ahead and plug in our force cosine theta. Doing so, we would get that the work force is equal to, don't forget the -1 times force cosine theta times distance. And rearranging this, because multiplication is commutative, meaning you could do 2 times 2, 3 times 2, it doesn't matter, you'll get the same answer. We can go ahead and see which of these answer choices does it match up with, and I'm leaning towards choice A, because if I multiply the distance before the cosine theta, I get something that looks like -1 force times distance times cosine of theta, which simplifies to work of friction. Here, let me write this up here. Which simplifies to work friction is equal to negative force times distance cosine of theta, which does in fact lead us to choice A. I hope you guys enjoyed the video. If there's anything that you guys didn't understand or would like me to go through again, please comment down below and I'd love to answer your questions. I know that I'm doing the Unit 3 practice problems before I've made the Unit 3 unit video. I'm hoping to get that out within the next few days, and I promise that I'll be getting the next units as the AP exam is coming up. I will be getting these unit exam videos um, faster up. I don't know about the exam walkthroughs. The exam walkthroughs might take a little longer to get to, but I can promise you that I will get them all out before the AP exam. I hope you guys enjoyed the video. With that being said, continue your prepping and remember to enjoy life.